Thanks for attending to this event. And since the release of Redis 6 is near, at least of the first release candidate, this is what I'm going to tell you today. But you know, the list of features usually are not particularly exciting, so we'll try to cover the backstory behind a few of the points that compose the Redis 6 release. And so, let's see to start what is inside this release. Okay, so this is the list of features that we have in this release. It's quite a lot of stuff compared to our average release. As you can see, there are many big features. Some of the features are waiting for years in order to hit a stable release. Just a quick listing. ACL is the access control list. You know, in the past, you could access a Redis instances using a password, but it was like a single user that was able to do everything. The only mechanism that we had to prevent certain commands to be called, like administrative commands that are dangerous, was a command renaming mechanism. So if there is a very dangerous command, you can rename it to a very unguessable string, and then only the system administrators can call this command, because otherwise it's not possible to guess what the command name is. We managed to stay 10 years with this system, but then we needed full users in order to model more interesting levels of not just security, but also of operational safety in order to isolate stuff. RESP 3 is the new protocol. It's opt-in, but we will see what advantages it provides. So we don't force clients to switch. The connections start in RESP 2 mode, the old protocol. But if clients will uncheck the new protocol, they will see a great deal of advantages. Client-side caching support. The modules APIs have a lot of new things. Diskless replicas, because the master, in the master, it was possible already when Redis creates the first RDB file to transfer to the replicas for the first synchronization. It was already possible to stream the file directly to the sockets instead of persisting it to the disk and then sending it to the replicas. But now this is also possible in the replicas side. So the replica receiving the first file for synchronization will avoid saving it to the disk, but will load the file directly from the sockets. This is a trade-off, of course, between memory usage or operational safety, because the replica will need to throw away its memory content to start loading it. Otherwise, it is also possible to use an alternative mode where the old content is saved, the new is loaded, and then the old content is thrown away. But in that case, the trade-off is basically the memory usage. Then there are I/O threads that we will see in depth later. More cluster tools, especially the cluster tools were ported basically from a Ruby script to C coded inside the Redis CLI. And then there is the new cluster proxy, because we saw that the client ecosystem adapted very slowly to Redis cluster. Writing a client library is a lot of work. Also adding support for the Redis cluster is a lot of work. And this work must be repeated again and again and again for every client library. So what we thought was maybe it's a good idea to write a proxy so that normal clients without cluster support can connect to this Redis cluster proxy, and the Redis cluster proxy will take care about talking with many instances at the same time. And then there is DiskQ, which is actually a different project than Redis. it was originally a Redis fork, and then this queue is going to be rewritten as a Redis module. And we will soon see what this queue is, but in general is a message broker, like RabbitMQ, or like the other message brokers based on Redis itself, like Sidekick and other libraries like that. So the release that we are going to ship this Christmas is called Redis 6, but actually it's release number 12, because we had like releases like 2.2, 2.4, and at some point I thought this is also because Redis doesn't use semantical versioning. So what's the point about making this confusing numbers? So now we go like Redis 4, Redis 5, Redis 6, like counting. It's simpler. So actually we had a number of releases in the past, and I don't know, I think it's interesting to see how the system evolved in the latest 10 years. I never did this in the past, but it was an interesting exercise. So in early 2009 we had the first stable version with strings, lists, sets. There was pretty much what you think Redis is already in the first release. And then 1.2 went out, and it featured sorted sets, which is now one of the top used data structures in Redis. And interestingly, we had the first protocol change, because the initial protocol was conceived to have just one bulk binary safe argument at the end, and this was not optimal. And we switched, but this was a hard switch. Like we are using a protocol, the next one is using another protocol, and the client ecosystem must adapt. Very hard switch. It worked, but Redis was not at the level of usage it is today. So now we are using a more gentle switch planning. And then there was the first version of the AOF, the append only file, which is the alternative and more safe persistence system. And then new commands and stuff like that. In 2.0 we added a lot of things that now are given for granted, but at this point Redis was already pretty popular, but still it missed so many things that now are obviously Redis. For example, the blocking lists were missed. So there were already libraries implementing like delayed jobs with Redis, but they had to resort to asking again and again if there are jobs. So you have to do continuous pulling in the server side. Instead, with the blocking lists, you just wait. If there are no items to fetch, the client blocks, and then you receive the new stuff. PubSub, which is one of the most used Redis features, happened in 2.0, and the hash type. So basically, before 2.0, there was no way to actually model an object if not storing like a JSON blob in a string. This was an important addition. Then there was this system called virtual memory that was able like to save large values of the memory to the disk in order to save memory. But then I realized that it was not what really I wanted to do. I wanted to do an in-memory system that had very smooth performance characteristics. And when you hit disk, things can work well, but it's not the same of a true memory system. Especially back then, you consider that in 2010, we had all these persistent memory technologies. There were like SSDs already, a lot of spinning disks, so no deal with this system. Yeah, and then we continued with all the other things. For example, in 2.6 we got Lua scripting, which is now a very important feature. And then in 2.8 we got the first release that was able, after a disconnection with replicas, to connect again and continue from where they left without doing again a bulk transfer in order to continue the replication. And finally in 3.0 the only feature was Redis cluster. And then geo-indexing, there was the debugger and all the stuff. In Redis version 4 there was the introduction of modules. And Redis 6 is very connected with Redis 4 because it's like if Redis 6 is modules version 2, because it contains a number of new APIs for modules, and you can write your own module in order to specialize your system based on what you exactly do. I see Redis usage at this point something like that. You use Redis, then you understand you want to do more, and then you maybe start to use Lua scripting in order to create your commands using Lua, and then you say, okay, now it's a couple of years that I'm doing that, and I want to squeeze every CPU cycle, and I want to simplify my operations, and then I write a module implementing certain application logics that I have in a way that are inside the server itself and are faster, less latency and stuff like that. Also, modules are very interesting for another reason. Sometimes you can have a process in your company that you want to standardize across all the development. For example, checking if a password is strong enough or not. You have places in the application where you have to do this check. What you can do is to write a Redis module to just implement this. I mean, it has nothing to do with Redis, but with Redis modules you get a protocol, and you have already Redis and the client implementations in your application. You get all the things you need to reply in order to start threads and do work in background, blocking operations, whatever you need. You get all the support basically. So some process like that makes sense sometimes to implement like a module, even if it's not database stuff, but you just want an interface with an external networked server to solve a given problem for your clients. And when you update, if you change the way you evaluate password weaknesses, you just update the module, and all your application will see. It's something like some microservice inside Redis, basically. And then finally, the latest release, which is Redis 5. Okay, I will read you the feature list. It contains streams, the new data structure after a long time, and also module improvements and the start of the cluster tooling improvements. As you can see, the Redis 5 release is smaller compared to Redis 6. One of the reasons is that in Redis 6, probably it's the release where I wrote a smaller percentage of the implementation myself. I received quite some work, and this was possible to improve in many different ways. For example, SSL was completely implemented by a colleague of mine, Yossi, so I had to do zero work about that. Also the proxy. The proxy was implemented by Fabio, also a colleague of mine. So basically, it's and many contributions also from other companies as well. So I believe that Redis 6 is the first release where something changed. It was an incremental process, but Redis 6 is really the result of many people working together at the same code base. While in the past, maybe it was more focused on what I did. So it's like if Redis finally grown up. Okay, so let's talk about ACLs. ACLs are basically needed by larger environments because of two main problems. One is security. And usually it's the enterprise company that is in need for security, or because of certain regulations that need you to have different level of accesses. And this is normally what a large corporation needs. But there is another very strong need for ACL that even as much smaller teams will feel they need, which is separation of concerns. For example, we talked about delayed jobs, which is a very, very common use case for Redis. So you have to send an email in your application, you just put a job inside a queue and then wait for it to be processed. And you have workers that will send the email. Now, maybe you use a library in order to implement that. Sidekick is a popular one. And this library was not written by you. And you just download it from GitHub or whatever. And then you are connecting this app to what could be your production database. So this app could do everything. Delete your data, read your data, and send it on, whatever. So it's also very important that you can see this client should be only able to do that and that and that. Also because of bugs. For example, you write a Redis component that just operates in Redis in a given way, and you don't want, for example, the new developer to write for error just because she was or he was testing stuff, flush all, and destroy the whole database. So with Redis ACLs, you can say two things. I have this user, and this user is limited to sending just these commands. And also you can say there is a limit in the keys that the user can touch. And you specify such keys using a pattern, basically, like a regular expression, a limited regular expression, a glob pattern is called, like asterisk and stuff like that. So the next time you download some library, you connect it to Redis, but you give just the ability, for example, to use the list operations or key matching operations or stuff like that. The ACLs are very simple to describe. There is a language that describes to Redis this ACL, and you can have an ACL file, and you can change interactively what a user can do and can ask Redis to rewrite the file for you. Another very important feature in Redis 6 is I/O threading. There is always this dispute in Redis, in the Redis community about the fact that Redis should be threaded or not. And it's many years that this discussion happens. In general, our vision is that it's better to run multiple instances because of a number of reasons. But in general, you get better scalability, and also dealing with a single instance and a huge data set is problematic also for other reasons about how the Redis core works. However, at some point I started asking myself if it was possible to get some advantage of threading without the complexity and the stability issues and the slower development that threading brings in. What I thought was that perhaps it was possible to just thread a small part of Redis that takes a very large chunk of CPU usage. And this part is basically when we read and write to the sockets. So if you profile Redis and a high load Redis instance, you will see that like 70% of all the time that Redis spends is spent in the write system call, just the write system call alone. So what we do is, with I/O threads, to take Redis single-threaded, and once we process all the clients sequentially, because from the outside the feeling should always be that every command is atomic, isolated, and so forth. We have the clients with the output buffers already populated. What we need to do is to take these output buffers and we need to write stem to the sockets. At this point, Redis is single-threaded. Just at this point, it starts multiple threads, performs the writes in parallel, and in this code section, as long as the thread entry point just touches the client structure without touching anything, we were sure that there are no race conditions, and then we return single-threaded again, and we continue with the normal path. So I tried to implement this only to discover that actually the work in order to synchronize the threads was equivalent to calling write. So for some time I didn't continue the implementation, and then I returned to it using a different trick. Instead of using mutexes and conditional variables and stuff like that, basically the threads always wait using a spin loop, a spin lock. So checking again an atomic variable, and then when the main thread wants the threads to process the I/O, it sets a single global variable and they start. So basically, in this way, using just an atomic variable, there are no syscalls involved, and it works very well, because if you can accelerate this 70% using 4 or 8 cores, basically the total speed of Redis increases 2 times. And it's already a good result for people that just don't want to switch to a multiple instances setup, but want just to basically accelerate a single instance. However, there is a problem. These threads spinning will consume a lot of CPU. And this is not very good from an energy standpoint, also from an environmental standpoint. So what happens is that we use the mutex, but the mutex is checked just from time to time in order to see if the traffic is low again, and if there is low traffic, it will return single-threaded. So it's like, it's like a turbo system. When there is a high need for speed, there are these threads starting, and then they sleep again when we return single-threaded. Okay, another thing in this release is DiskQ. I want to tell you a bit about DiskQ. So basically, one of the very popular Redis use cases is to do basically the backend of some message broker system. What's interesting about this use case is that many people don't even realize they are using Redis. They download one of those libraries for delayed jobs, and one of their requirements is to install Redis, so they do, but actually all the work is done by Redis almost. So Redis is not just a store, but a very popular message broker. So I started to think, what about taking the same philosophy of Redis, in memory, C-coded, minimalist, and write a system of just for messaging about that. Also, once you have to deal just with messages, you can rethink certain things in Redis, like for example, change the way it is replicated. So I started to design this system, forking Redis, removing the Redis part, and just taking the networking layer, the protocol, all this stuff, and implementing DiskQ. DiskQ works like that. Basically, you have the same protocol of Redis as similar commands. You add a job, and the first difference with Redis is that DiskQ is synchronously replicated, because usually you want a very strong guarantee in messaging that the message will be processed at least once. And in the face of node failures, the only way to have some safety is to use synchronous replication. So the job is propagated to multiple nodes, they acknowledge the first node that the replication of the job happened correctly, and then the client is notified that everything is okay. And if you use the replication factor of 4, for example, up to 3 nodes can fail, and the job will be processed still. So another difference is that this queue is multi-master. So you can access a given node or another given node, and it will work the same. After this message is replicated, the nodes that are connected in a full mesh will exchange information about the fact that the node that a given job was processed or not. A lot of work of this queue is to, even if it can just provide at least once delivery guarantees, and this is a law of physics, that it's impossible to do better than that. It uses a lot of algorithms in order to approximate single delivery. So basically what we want to do is to avoid stupid multiple deliveries. So if a given, so the job is in four nodes, and one will provide it to a given worker. The worker, when the job was processed, will reply back to the system and say, okay, I can acknowledge this job was processed. And then we can imagine now that the node that received the acknowledge will fail for some reason. And then there are other 3 nodes that have the job. And these 3 nodes have timers, because at some point there is a retry timer in order to try to deliver the job again. But if the failure node will be back again, it will immediately inform the other nodes that the job was processed, and then a garbage collection process will happen and the job will be removed completely from the system because already processed. So basically, this queue is a better version of Redis messaging. However, there is a problem. After I forked Redis and I was about to release this queue version 1.0, I discovered that to think that two implementation synchronized for the common parts was a nightmare. Continuously merging commits from Redis to this queue and the other way around. And then this queue specialized even more, and it was impossible to merge stuff between the two. So at some point I thought, what about being able to have a module API for Redis so powerful that it can model this queue? When I started to think like that, the Redis modules API was nowhere able to be so powerful to model something like this queue. But now it is. And finally it is possible basically to call this queue back home in the Redis home. And so we will see also a release of this module for Redis 6. Okay, I think I ran out of time at this point. Yes? So I hope you will do the effort, basically, if you use Redis, of trying the new Redis 6 features, because sometimes new features that are very important for users take like 1 or 2 years before people discover that they exist. So please, if you are a Redis developer, just take 1 day in order to play with the system. Write me emails if you find some it's not working as expected. But the new features sometimes that now looks distant are the big features of tomorrow. We saw the history of Redis. Lua scripting is not much older. Redis cluster is not much older. Even blocking operations in lists that are now given for granted. So probably there is some Redis 6 feature today that is going to be the main feature of tomorrow. So I hope you will have fun. Bye. Thanks.